Hello guys, welcome all of you in another lecture. Okay, so quality of service. So quality of service, some kind of uh, there are some techniques which will help to achieve quality of service. So the data transferring is a service. So to improve or enhance the speed and the errorless service, so it is called quality of service. Okay, so firstly we will discuss the requirements of quality of service, then secondly we will discuss the techniques for achieving good quality of service, how we can achieve good quality of services. Okay, so requirements. So how string the quality of service requirements are. Okay, so for email, reliability high, delay low, jitter low, bandwidth low. Okay, this kind of quality we need for an email. File transfer, reliability high, delay low, jitter low, bandwidth medium. There is no issue of bandwidth. Okay, web access, when we access the website, reliability high, delay medium, it's okay with medium, jitter low, bandwidth medium. If you're wondering what is reliability, delay, and GTO and bandwidth, then you just could reliability is a kind of a word when something is reliable. Is reliable means we have the trust. It has the trust to it can do the task. That is reliability. Delay is a kind of delay when it's in terms of time, when the service is some bit of slow, that is called delay. Jitter, jitter is something buffer. Bandwidth, bandwidth is a the is it's a bandwidth is a kind of uh, frequency. In terms of frequency, uh, in what frequency we can transfer data, that is bandwidth. Okay, so file transfer and our access. So this chart is the requirements. When we video conferencing, reliability will be low, but the delay is high, jitter high, bandwidth high. So how we can achieve? So there are some techniques, though. So the buffering is the technique. What buffering is? Have you when you go to the YouTube and when you have no data or some kind of overload, so there is a kind of circle moving in front of you, that is buffering. Packet departs source, packet arrives at buffer, packet removed from buffer, time in buffer, gap in playback, smoothing the output stream by buffering packets. How we can smooth? So like for example, there is a conference hall. Okay, there is a conference hall in your college, and its gate is very small, and there is a lots of student outside. They want to enter in the hall. So what will be the technique to uh, get them into in tag them into it. Okay, so what we can do is we can queue them, or we can arrange them, we can say them come one by one. Okay, so that is the buffering. In the same way, the data packets, the data chunks are very large amount of chunks, and there is a small gate of your computers, how they would come inside. So we that's called buffering. So these packet arrives at buffer. Okay, so in the same way, first one comes, then there is a time, then second come, then three are coming in the at the once. So what it does, it arranges them in the each time distance and in a sequence as it is followed. Okay, now leaky bucket. So what is leaky bucket? uh, Leaky bucket is a bucket. Okay, we can uh, fill it with a busty flow, but when we uh, and we can release it with a fixed flow. So this is the busty data. First 12 MB per second, then 2 MB per second. But what it does, it fixed rate data 3 MB per second. That is the beauty of leaky bucket. Okay, that is the algorithm. Host computer and the network. Packet, unregulated flow. Okay, there is not regulated flow. So what it does, it converts this unregulated flow into the regulated flow. Okay, and leaky bucket implementation. So we can use a queue to implement leaky bucket. Queue is a data structure. If you are not aware of the queue, you will probably learn in the programming what is the queue. Okay, this is arrival for this card. Okay, remove packets at a constant rate. Okay, thank you so much. That is the another token bucket. The same, we are using water in it, and it is a token. The same process. Okay, thank you so much.